Hey guys, welcome back. This is Professor Hank, and in this video we're going to review passing arguments to procedures, calling procedures, returning for a procedure. Specifically, we're going to focus on what happens if you want to pass more than 4 arguments to a procedure in MIPS, right? And so, as you probably remember, in MIPS you have 4 argument registers, right? You've got these A registers, which are A0, A1, A2, and A3. Okay, so those registers reserved for this purpose. So the convention is that when you call a procedure, you want to pass in some arguments, you put those values in these registers, right? And then the procedure, whoever writes procedure, expects that the arguments are there and are ready to be used, right? But what happens if you have more than 4 arguments that you want the procedure to work with, say 6, right? Well, if that's the case, don't have enough registers, we got to put that information somewhere else for the procedure to retrieve. So that place is the stack, right? And so remember, the stack starts at the maximum address of the program. Okay, you've got your reserved area for your program, right, your reserved memory space. You've got your text space, right? Then you've got your fixed data space, right? That's your data segment. Then you've got dynamic data, okay? And then you've got your stack, right? Which starts at the very top. The stack grows downwards, right? So if this is the very beginning of your program, memory address 0, relative to the beginning of the program, then up here is the very top of your program, right? This is the very end. So, you know, this is something like F, 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 C. And actually, I think it goes up to 7, F, 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 C in hex. But anyway, so the stack grows downwards and the dynamic memory area grows upwards, right? So whenever you want to make room on the stack, you got to subtract some bytes from this memory address. And so the stack pointer is initialized with that value right there, okay? So to make it simpler, so we don't have to worry about you know, hexadecimal number memory addresses and, you know, every other part of your program, you know, I'll just make up some memory addresses, right? Some numbers here, okay? So if this is our stack and the stack pointer starts off initialized at the very top of your program, okay? Let's say that that memory address, just to make it easier, is, I don't know, 1,000, okay? So when your program gets set up to call the procedure, it puts the arguments into the argument register. So let's say we got 8, 6, 7, 5, 3, and 0. Okay, so the 8 goes in the 0 register, the 6 and the 1, the 7 and the 2, and the 5 and the 3, right? But I still have the 3 and the 0, right? Well, where are those going to go? They're going to go into the stack, okay? So in order to do that, what do I have to do? I have to subtract from the stack pointer to make enough room. So in this case, I'm using integers, so I want 2 words worth of memory freed up on my stack, okay? So basically I have to subtract 8 from that stack pointer to get it, so the top of the stack is now here. So that would mean that the value in the stack pointer register is going to become 992, right? It was 1,000, now 992. Made room for 8 bytes. Okay, so once I've done that, I've got enough room for 2 numbers, right? So at the stack pointer address itself, right, I can go ahead and put say my 0. Okay, and then if we add 4 to that, right, then I'll go ahead and put my 3. So if the very top of my program is memory address 100, then 4 bytes in, it at 996 would be the beginning of the word where I put the 3, and then at 992 would be the beginning of the word where I put my 0. Okay, so now when that's all set up, I call my procedure, and now I've got the arguments in their places. Okay, so I've got the 8675 in the registers, and I've got the 3 and the 0 in the stack. Okay, now the procedure already knows about A0, 1, 2, and 3, okay, by convention. Now, it's going to expect that data is in the stack for it, okay, but the procedure itself can expect, since it's been written, to look in the stack for those 2 values, right? Just hard code in the memory addresses, or use instructions to go back and look at these values, right? So inside the procedure, we could have something like this, right? We could say, oh, well, let's load into T0 0 SP, right? And that would retrieve the 0 and put it into T0. Okay, fine. Okay, but we can generalize this too, to where we can say, oh, well, in the calling code, how about we use another register that's referred to as the frame pointer register, FP, right? And what we can do is we can put the starting address of this stack frame, right, where the bottom of it is, in which case that's 1000, okay? And then the procedure will know where the beginning of the data is that it needs to do its job, right? So this is effectively the bottom of the stack, right? And this is the top of our stack. So what does this do? What does this give us? Well, SP has got the memory address at the top of the stack, and FP's got the memory address of the bottom of the stack, right? So instead of doing something like this, right, what we can do is we can say, oh, well, let's go ahead and load in the first argument that's relative to the stack, right? So that's relative to the frame pointer. We can say, oh, all right. So if we're going to grab that bottom value, it starts at 996. So that's going to be -4 away from that frame pointer. Okay, and so then we put that inside of, say, T0. Okay, and then if we want to get the value that's at the top of the stack, well, then we just say load word star T0 $T0 -8. Okay, so we can do that, and we can also check to see if there's any thing in the stack for us, because we could just compare the contents of this frame pointer register to the stack pointer register. Okay, so if they're not the same, right, then we can tell that there's something in the stack for us. So we could say, all right, well, you know, we could do a branch instruction, right? If the frame pointer register and the stack pointer register aren't the same, then go do something, right? Or if they are the same, go do something, you know, jump somewhere. Okay, so what else can I tell you about this? Okay, so in Qt-Spim, FP isn't explicitly defined, right? So what they do is they use the S8 register in its place, right? So S8 becomes the frame pointer register in Qt-Spim. Okay, so let's go ahead and take a look at some code that can show you how this could work. Okay, so in this program, I need to pass more than 4 arguments to a procedure. Okay, so let's set this up. So in my main, I'll go ahead and set I'll load into A0 8, I'll load into A1 6, I'll load into A2 7, and I'll load into A3 5. I got 2 more values that I want to give to the procedure. I'm out of registers. So here's what I'm going to do. I'm going to make some room on the stack for the other 2 arguments. Right? So 2 integers, 2 words. So here's what I'm going to do. First things first is I'm going to use that frame pointer register. Okay? So here's what I'm going to do for that. I'm going to set S8 to the current contents of the stack pointer. Okay, so that's going to preserve the bottom of my stack, the memory address of the bottom. Okay, so then I'll go ahead and make room on the stack. All right, so this records the bottom of the stack, right, which is also the beginning of the stack frame, right? It's one of the bounds of the stack frame that my procedure that I'm going to call is going to use, right, for those 2 arguments. So let's make some room on the stack. So I'm going to need 8 bytes because 2 words. Why 2 words? Because 2 arguments. Okay, and then we'll go ahead and copy those values onto the stack. Right, we're going to push those values onto the stack. So let's see here. So I'm going to need the 3. So I'll put that into T0, and then from there I'll put the 3 onto the bottom of the stack. So I could do this a couple different ways. I could use the frame pointer at the bottom of the stack as my offset, or I could use the top of the stack. So I'll just go ahead and use the top of the stack here. So we'll store T0, 4 bytes from the top of the stack. Okay, so using the stack pointer that contains the memory address of the top. Okay, all right, so that's going to put, this will push 3 onto the bottom of the stack. Okay, and then we'll do that 0. Okay, and that's going to go onto the top of the stack. Okay, and then we'll push 0 onto the top of the stack. Okay, so now my stack frame is set up, and that means all the arguments are ready to go. Okay, so now I can call my procedure. Okay, so let's call it. So the procedure, I'll call it, what we're doing with 6 numbers, what we'll do. We'll just do something simple, we'll just add them all together, okay? So jump to add 6, okay? So when we come back, you know, we'll print the result and then we'll quit, right? So I'll fill that in after I write the procedure, okay? So here's my procedure. Okay, what's it do? Adds 6 numbers and places the result in B0. And where does it look? Arguments can be found in A0 through A3 and the stack. Okay, so let's go ahead and do this. So what do I need to do? So I need to name this thing add 6. Okay, and A0 through A3 are already going to have their numbers, so I'll start doing the addition right away for those. So let's put into B0, A0 and A1 their sum, and then let's add to that A2, and now let's add to that A3. Right? Okay, so now we have to make a decision. Right? So this is where we're going to use the frame pointer. Okay, so I can determine whether or not there's anything in the stack for me to add, right, by comparing the contents of the frame pointer and the stack pointer, right? So I could say, well, if they're equal, right, so if the frame pointer, which is being used as register S8, is the same thing as the stack pointer, that means that nothing was pushed onto the stack, right? So then I'll just go ahead and terminate. So I'll jump to a return label. Okay, so my return label will just say, let's go ahead and jump return to, or jump register the return address register. So we're just gonna go back, okay? But otherwise, let's get those values out of the stack and add those to V0 as well. So I could use SP here, or I could use S8 to get those values out. Okay, now if I use FP, right, that S, which is my S8 register here, if I use that, then that has the memory address of the bottom of the stack. So if I subtract 4 from that, then that's going to get me the beginning of the bottom value in the stack. Okay, so let's load that into a temporary register. Okay, so -4, S8. Okay, so we got that, and then we will go ahead and add that to V0. Okay. So V0 and T0. Okay, and then we'll go ahead and retrieve the top value in the stack. Okay, which would then be -8, S8. Okay, and add that value we just retrieved. Okay, and then we're done, right? So we can go ahead and return. Okay, so when we get back, let's go ahead and print that result. Okay, so what are we going to need? We're going to print an integer, so we'll have to take the value in V0, which was returned by add 6. Okay, and we'll put that into A0. Okay, and then we will load into V0 the system call code for printing an integer, and then we'll tell the system to print the integer. Okay, so I think that's everything that we need. Let's go ahead and test this. Let's go ahead and run it and see if we get a correct answer. 29. So looks good, right? 8 plus 6 is 14, plus 7 is 21, plus 5 is 26, plus 3 is 29, plus 0 is 29. So we got the right answer. Okay, so let's go ahead and run this again and trace through the code and see how everything is changing, how everything's happening. Okay, so get through all this preliminary stuff. Okay, and all right, so first instruction was recording where the bottom of the stack is. Okay, so if we go take a look in our registers, right, there's the stack pointer register, and there's S8, which is functioning as our frame pointer register. So we've got that squared away. Okay, and now we're going to go ahead and put 3 on the bottom of the stack. Now we already, with these first few instructions right here, right, we already put the 8, 6, 7, 5 into the argument registers. Okay, so we're good with that. So now we're going to put the 3 and the 0 onto the stack. Okay, so let's do that. Okay, and now let's go examine, before we jump, let's go examine the contents of our stack. And you can see there's the 0 and there's the 3. Okay, so let's go back and make our jump. Okay, so now we're in the add 6 procedure, and so it's going to start doing its adding, right? Adding the first 2 arguments, putting in V0, right? And we can see that V0 has got the result. Now that's an hexadecimal, so let me change that back to decimal so it's easier for you to see. 8 plus 6, 14. Okay, then we do the next addition, which is adding the contents of the A2 register, so we're at the 21. Then for the A3 register. Now we're checking to see if there's anything in the stack here by doing that branch instruction. Okay, now since they're not equal, there is stuff in the stack. So now we go to the stack to retrieve those values, right? Loading the word, or doing a load word instruction into a temporary register, getting value from the stack relative to the bottom of the stack using S8, which is what QT-SPIM uses to represent the frame pointer register. Okay, so we grab that. Now you can see T0 got the 3, retrieved it from the stack. Okay, so then that gets added to V0, and then we go back to the stack and grab the 0. You can see the T0 register updates, and then we add that to V0. Now V0 didn't change because 29 plus 0 is still 29, and now it's time to jump back. Okay. Now there's one thing that I forgot to do. I forgot to reclaim our stack memory back in the main procedure. So I'll do that. I'll fix that here in just a second just to show you. But anyway, so let's go ahead and print out the number. So next instruction takes the number returned in V0, puts it in A0, right? So now we can put the right system call code into V0, which is 1 for printing out an integer. Then we can ask the system, hey, go ahead and print it out. Okay. Now, had one thing I forgot, which was to reclaim my stack memory, right? So let's go back here and do that before the program quits. So reclaim stack memory, which is just undoing what we did at the beginning to get that stack memory, right? So we're freeing up the memory we used in the stack. So if we subtracted 8 bytes from the stack pointer, then we'll go ahead and we'll put those 8 bytes back. Okay, let's see here. So there we go. And you know, it probably would be a good idea for us to reset that frame pointer too, just in case any subsequent code was going to be using it. But since this is the end of the program, we won't worry about it. It's not going to matter. The program's over anyway. Okay, so that fixes our stack memory problem, our memory leak. Okay. All right, so I think that that's everything that I wanted to show you. So let me just go back up here and show you the code one more time here. So this is the main procedure. We're passing 4 arguments into the argument registers, but we want add 6 to have 6 arguments. So what do we got to do? Make room on the stack, copy those values onto the stack, then we make our procedure call. Okay, and then when we get back, we printed the result, and then we reclaimed our stack memory, and then we quit the program. Now in the procedure, what did we do? Once we jumped into the procedure, we added the numbers in the argument registers, and then we determined if there was anything in the stack that we needed to get. So actually, this procedure here could be used to add 4 or 6 numbers. Okay, but anyway, is there anything in the stack for us to get? There was, right? So we didn't jump past this additional section of code here, right? If S8, which represents the frame pointer register, and SP, which represents, which is the stack pointer register, if they were the same, then that would have meant that there was nothing in the stack for this procedure to go retrieve. So this part would have been skipped. But since they're not the same, there is something in the stack, so we're going to grab it. So here we're grabbing the value that's at the bottom of the stack. That value starts 4 bytes away from the very bottom memory address, okay? And S8 again is representing the frame pointer. So we grab that, put it into T0, then add to V0 the contents of T0, and then similarly repeat that logic, but we go 1 word further away from the bottom of the stack. So we're at the top of the stack now. And so we retrieve that value, add it to V0, and then we jump back. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.